Okay, we're given formulas for the first derivative and the second derivative of some function, which we don't know what it looks like, and we're not going to bother trying to find out. But we would like to answer these questions right here using the first derivative test and the test for concavity. Okay, so over here we're going to try to find the critical numbers by setting the first derivative equal to 0, and then finding out for what values of x the first derivative does equal 0. And this factor never equals 0. I don't care what number you put in here for x. But if x minus 3, the quantity squared, equals 0, then x equals 3 and x equals 5. So those are the critical numbers right there. We'll put them on a number line and apply the first derivative test. We want to find the sign of the first derivative in each of the intervals created by those critical numbers. So, for example, we choose test numbers in each interval. So let's find f prime of 0, which is to the left of 3. And we can just look at the factored form. We put 0 in for x. This first factor is always positive. That's why I have positive right there. If I put 0 in here and then square that quantity, it doesn't matter what I put in for x. If I square this quantity, that's going to be positive. So those first two factors are always positive. But when x is 0, this factor is negative, which means the first derivative is negative. Tangent lines have a negative slope, so the original function is decreasing. And similarly for these other two intervals. Okay, so these arrows tell you that the function is decreasing to the left of 5 from negative infinity to 5, and it's increasing from 5 to infinity. And there's no local maximum because we don't have a picture that looks like this. But we do have a local minimum at 5. We don't know what the local minimum value is, but it's f of 5, whatever f is. Okay, now to apply the test for concavity, we want to know when is the second derivative equal to 0. And again, this expression right here is never 0. E to any power is going to be positive, and then we take the opposite of that. This first factor is always going to be negative. So we used to call them hypercritical numbers. I don't see that in textbooks anymore, but places where the second derivative is 0 are at 3, 4, and 7. So similarly, find out the sign of the second derivative in each of the intervals created. For example, f double prime of 0. Again, this first factor is always negative. And then just picture substituting 0 in for this factor. That'll be negative, negative, negative. The product of 4 negatives is positive, which means the original function is concave upward. I like to think smiley face, positive. And negative is a frown. So that's what happens if f double prime of 3.5, because we'll get negative, negative. This one will be positive. This one will be negative. So we've got 3 negative factors, negative, and similarly for the others. Okay, and so there's the intervals of concavity, and points of inflection are where the concavity changes. So 3, 4, and 7 are all points of inflection. There you go. Hope that helped. If you have any questions, post a comment.